All right, welcome back. So, at the beginning of the chapter, we talked about the steady decrease in the average number of hours worked since the 1800s. So, first, we've seen an increase in non-labor income. So, things like the increasing value of houses, more investments in 401ks, more government assistance. But there have also been increases in real wages over that period. And we saw hours worked in the United States increase in the 1970s and the 1990s. This happened right when real wages stagnated in many industries. So these findings are very much in line with the simple model that we outlined in the previous lecture. So excuse these poor, low quality images taken from the book. I couldn't find anything good enough online that matched what was in the textbook. So now in the previous model, we assumed that workers could choose any combination of hours. But for many jobs, or most jobs, that's unrealistic. So part-time workers may be limited at 20 hours per week on the high end, or some point short of 40 hours. But let's use 20 hours for the sake of this example. Likewise, full-time workers may be forced to choose between 40 hours and overtime, but nothing below 40 hours consistently. So figure 5.7a and 5.7b in your text to pick these two scenarios. So on the left, we have figure 5.7a. This individual would only be able to maximize utility between 0 and 20 hours of work, depending on where the indifference curve was tangent to the wage line. So it could be anywhere between those, between 0 hours and 20 hours, and that's where they're going to choose to work. So basically, we're only talking about the downward sloping part. Remember, that's because work hours increase as we move to the right. Excuse me, as we move to the left. Leisure increases as we move to the right. Likewise, in figure 5.7b, here on the right, workers can only choose between 40 hours and above. So it limits them to the slope part above the 40 hours per week. So this is something that's more realistic to what we would see in the real world. So let's think of some of the policy implications of this. What will be the effect of increasing welfare programs on the labor supply? I don't want to delve too deeply in this class into applications of this model outside of what's going to be useful for HR, but I think this would be a good exercise to explore and try to apply what we've been learning. So let's suppose there's a situation where Congress decides to give everyone in the United States of working age a $4,000 lump sum payment per year, basically like a universal basic income. And they're going to finance this by increasing income taxes. So it's going to move the average rate for income taxes from 15% to 20%. So we're going to assume that the tax is not progressive. So basically, it doesn't increase as you, or the percentage doesn't increase as you earn more money. It's going to be the same at all income levels. So basically a flat tax, in this case, a flat tax of 5% or an additional 5%, which brings us up to 20%. So now in this case, what's going to be the effect on hours worked? This is important because if people choose more leisure, then this could have the opposite result as intended. It could actually make people worse off financially. So let's suppose that initially the worker has an after-wage tax, or excuse me, an after-tax wage that's represented by the line AB. It is going to be 85% of their market wage because we have the 15% income tax. Now, if Congress would pass the welfare program, everyone receives $4,000. So it's going to increase the minimum that an individual earns from 0 at point B to $4,000, which is going to be labeled point C. If this happens, the new wage line is going to be CD. It's going to have a shallower slope because now the tax has been increased to 20%. Now, the effect of what this is going to have on workers' leisure work decision is going to depend on where the individual was before this reform was passed, where they were along that line. So let's say the individual was at point B. They were outside the labor market. They were choosing not to work. It was all leisure. They would go from point B to point C. So they're going to be made better off. They're going to have, greater utility, but they still receive a disincentive to work. So now they make $4,000 more than they did before, but they have a lower benefit from working, but because the slope is more shallow. The same effect would hit people working less, or people working to the right of L1, working fewer hours than L1. Both the income effect and the substitution effect is going to encourage them to take more leisure and work fewer hours. At point E, where the two wage lines cross, individuals will be neutral. They'll be no better off under this, the tax with a lump sum payment, and they will be no better off than before. So this is called the break-even point, because the individuals, they basically break even from this. There's no change in their situation. For people that work more than the break-even point, so to the left of L1, the effect is going to be unclear. Their earnings will decrease, which would encourage them to work more hours. But on the other hand, there's a substitution effect going on. The cost of leisure is now lower. They have that lower opportunity cost because the wages are lower. So they're foregoing less money when they opt to enjoy leisure rather than working. So the effect is going to be ambiguous. It's going to depend on what each individual's utility curves are for this point. We would need to know their indifference curves to figure out if they're going to work fewer hours or more hours. Now, before we end, I briefly want to touch on the life cycle model. Lifetime utility is a function of consumption goods and services and leisure, and it's over the entirety of their earning period. It's not just like the previous model we were looking at, which was just specifically like this week, what I'm going to choose right now. Your textbook has like a formula for that. I'm not going to make you memorize that. This isn't a theory heavy class. This isn't for people that are specializing in economics. This is just, again, like I keep saying, stuff that you could take from this to use in your career in HR. So we can talk about some of the implications of this model, what's going on. So in our previous model, like I said, we assumed that workers tried to maximize their utility from leisure and consumption. But now we're going to introduce the element of time. So it's not just at that one point in time. It's going to be over the entirety of their lifetime or their working life. So workers, they can save for the future, and they can use that savings to consume or to enjoy leisure then. So people can choose to supply different hours of labor at different times in their life. And we should be able to notice that from our own lives. We tend to see a hump-shaped or an inverse U-shaped earnings profile for a person's life. And that's basically what we see in this chart here. As a person gets older, their income increases up to a certain point, then it kind of levels off and even decreases a little bit. So as time goes on and a person receives raises, they get higher wages from maybe becoming more productive, from jumping to new jobs. The substitution effect would suggest that they would work more hours as leisure becomes relatively more expensive. The income effect would be ambiguous, but we need to introduce a new concept to really understand this. And we're going to call this the permanent income. People don't just use their current income to plan their consumption, to plan how much they want to work versus how much leisure time they have. They also consider their future income. The wage increases would not carry with them the income effect that we've been seeing in our our one point in time model, because the increases are usually anticipated in their leisure work decision already. So we might not be able to anticipate when a raise is coming or how much it will be exactly. In some jobs, you do have a schedule and it increases. Every year you get the cost of living adjustment. Maybe every so many years you get another bump up in salary, just like moving up from, I guess, as I'll say, more experienced. But we do know these increases are going to occur in most jobs, even if you don't have that same sort of schedule of raises going on. So the only time we would expect the income effect to occur from a raise over a worker's lifetime is if the wage increases is completely unanticipated. Another question, does this hold in the real world? Again, this makes sense looking through the model, but if we look at what's going on in real life, does this hold? There's been some research into that. I have citing here a paper called "Do Consumers React to Anticipated Income Changes? Evidence from the Alaska Permanent Fund." Basically, in Alaska, they pay Alaskan residents a lump sum every year. Researchers looked at this and found that the payments do not change the spending habit of Alaskans. They anticipate the future income stream, and they adjust their annual spending accordingly, knowing that it's going to come. I do this in my own life explicitly, but I'm an economist. I've learned about this, so I'm probably not the best example. But we do tend to see people taking into account how much money they're going to make. The textbook gives an example of buying a house. Oftentimes, if you watch like House Hunters or something on HGTV, they always seem to go above their budget. Some of the reasons why these younger couples in their, they're in their like 30s are doing this is because they anticipate a higher future income. So even if it's a little tough to do right now, eventually they anticipate it's going to be easier as their income goes up over time.